I'm going to talk about the drill down feature in PacketScan. All calls, either active or completed, can be monitored and drilled down into detail for further analysis. The calls are color-coded, either complete, incomplete, or active calls. The active calls are blue or light blue, so you can select the call, select the magnifying glass icon, and drill down into the actual call, and we'll show you the packets left and right, and at the bottom we have a set of tabs with the different features for analysis. The first tab is the RTPP statistics tab, which gives you the detail on the left and right side of the call details, the IP, the port, the packets, MOS scores, discarded packets. The next tab is the RTPP packets, which gives you a summary of each sender report or receive report, SDS, whatever. The gap graph gives you a running view of the packet graphs over the duration of the call. And we can either do a 3D or a 2D. The jitter graph is the same. It shows the jitter that's occurring over the duration of the call. Again, available in 3D view or 2D view. The gap distribution gives you the gap statistics, the gap statistics. So basically, you would expect to see a 20 millisecond packet for a feed time of 20, and then the gap shows you the variances of the packets over the duration of the call. The jitter distribution graph is the same. It shows you most packets are showing zero jitter, with some packets with a slight amount of jitter, 1-2 milliseconds. The MOS score is a mean opinion score of the quality of the call based on the packet conditions. If there's any event in the transmission, such as packet loss, out of order packets or whatever, that would degrade the quality of the call, the MOS score would degrade accordingly. There's also something called recency, so that in some cases you can see the score might go down, but over the duration of the call it would go up again, since a packet event that occurs at the beginning of the call tends to be forgotten over the length of the call, and so the score will reflect the increasing quality of the call again. The InBand events are the InBand DTMF and or DTMF or DMF digits. So we have the digit decode as well as the on time, the power, and then a breakdown of the frequency of the dual tones. The RTP events, these would be, there's none in the call, but these would be the out-of-band DTMF, MF, or RTP events. Send 1 kilohertz test tone, busy tones. The wave graph is an oscilloscope that shows you the call's down again. It's an oscilloscope that shows you the actual that's what I'm trying to avoid. When this thing stops, I don't have the spectral. Okay, we're going to zoom into this call, hit the magnifying glass, and we're on the Spectral Display tab. This is the one of the being someone from the old world that used to use spectrum analyzers and oscilloscopes. This is a great feature for those of us who don't trust what we're seeing as far as the packets are and want to actually look and see what's going on with the real traffic that's going through the network. And so this is a way to view real-time what's happening. So we have a spectrum analyzer and we have an oscilloscope, which allows you to go in and if there's any artifacts happening, dropouts, clipping, whatever, you might have a chance to see it here. RTP events are out-of-band events such as MF and DTMF digits. InBand events are DTMF and MF digits sent in-band. We report the digits, on-time, power, and frequency breakdown. So we have levels. If there's any twist, you could see it in the frequency and power reports. The MOS graph is the mean opinion score. This is a score based on the quality of the packets that are being sent. If there's any packet loss or similar impairment to the network, the mean opinion score will drop off and be reported. The counterpart to this is the R factor. The MOS is score based on excellent, good, fair, poor, bad, or 0 to 5. The R factor is a score that's based on a calculation from 0 to 100. That's based on the ITUT original network definition plan, where the path was defined as a mouth-to-ear path in both directions, and a model was made to calculate the conditions over a telephone network, which includes things like side tone masking ratio, send loudness rating, receive loudness rating, overall loudness rating, impairment ratios, and it gives you a number, and then these numbers were basically mapped to actual live talker and listening MOS field tests where people were listening to or talking over circuits and gradient according to excellent, good, fair, poor, bad, and that was correlated together to derive a model that, in this case, now mathematically computes the MOS score. Okay, the wave graph gives you the oscilloscope to see what happened in band during the duration of the call. In this case, there's a sequence of tones and speech and digits being sent. The spectral display is only shown for active calls. This call's terminated. And finally, the R factor score, where we have the R factor. That basically these are the